Today we are going to introduce the so-called MOSFET. It stands for metal oxide semiconductor field effect transistor. Okay, since we have the bipolar junction transistor, then why do we need another type of transistor if they are both used in amplification purpose? But as we can review the characteristic of the bipolar junction transistor, we have a transistor like this one, for example. And if we have the source here, and in order to make the transistor goes into its working area, and we need to apply the bias voltage here. And this bias voltage will create an IP current such that this transistor turns on. And here we always need to have IB current here. And as we know, we have the power equal to I multiplied by the V, which is the current and the voltage here, and we have the power. And this will increase the power consumption of the whole circuit, and inevitably. And in most amplification purpose, I don't think this small power is the concern. But if we consider that if we are making a switching circuit, for example, when we have a transistor here, and this is, for example, this is 5 volts, and if I put 5 volts here, and this will make this transistor go into the saturation, right? And when it goes to the saturation, and the VCE will be equal to 0, and the output here will be equal to 0 volt. I mean close to 0 volt. But this will induce a lot of current go through here, and we also need a lot of current flowing through into the base in order to maintain that the transistor is in the saturation regions. Okay, and then we need the current, and as long as we have the current, and we have the power. And so we think about maybe there are one possibilities that we don't need to really turn on the transistor by using the IB to save some current. And this is maybe one of the reason, and also the main reason I try to introduce the Mosfet, because for the Mosfet is the basic unit to construct the digital circuit that we use today. And why we can eliminate the necessary IB current, because that we have the new structure of the transistor. Let's look at the N-channel enhancement mode MOSFET. Okay, we will introduce this word later. What is enhancement? Okay, and imagine that if we have the architecture of the transistor like this, we call this is the P material. Okay, and we have very small. We have very small M material here, M material here, and we have metal here. This is metal, and originally originally the source and the drain, they are not conductive, okay, because that we cannot have that N go through P and the P go through N, because we have the depletion region here. As we can see, we have depletion region. We have depletion region here. So the current is impossible for the current to flow through the N to P and the P to N. Okay. But we call this one the enhancement type. And if we put a positive voltage here between gate and the source, okay, and we have the positive charge here, because the positive charge here and the N-type material, I mean the electron will be attracted to this region. And we have the electron here, and this create a tunnel such that we can have the current flow through the drain and the source from here to here if we apply a positive voltage across the D and S. And now we can have the current flow through here because now we have a new tunnel. And here we say the three terminal of the transistor called the drain, which you can think regarded as the collector of the BJT, and this is the gate. This is the gate, which we can regard it as the base of the BJT transistor. And finally, we can have the source. You can regard it as the emitter of the BJT. And then the advantage is that there will be no current flow from gate to the source, because this is a isolated non-conductive material here. So the only way that we can create a tunnel is simply to apply the positive voltage between the gate and the source. So this is the basic structure of the Mosfet. And there are two types of the Mosfet. We just talked about the first type, we call the enhancement type. This is the symbol. Okay. And the second type is called the depletion mode, or the depletion type of transistor. For the depletion type of the transistor, originally it has a tunnel here. We have tunnel here. Okay, that's why we call it depletion. We call it depletion mode. We have a tunnel here, and if I want to operate the tunnel, and I can apply a negative voltage, but since it's easier for the manufacturing process to develop the enhancement mode, because it's simply we simply need to have the N-type material here. So now only in some cases that we need the depletion mode transistor. That's why we introduce mostly the enhancement mode transistor. And because originally we don't have the tunnel here, that's why we have the dashed line here. This is the symbol of the enhancement type transistor. But for the depletion type transistor, we have solid line here. That's the difference. So, and similar to the bipolar junction transistor, we have two types of the transistor. One is the N channel, and the other is P channel. Okay, so in order to, there's one of the application of this kind of transistor is that we can use a transistor here, and we can control the motor here, and this is we can measure the current here, and we can measure the voltage here. Okay, so we can use this one to turn on the transistor and let the motor turn on, and also we can turn off the transistor such that there can be no current flow through here, and then the motor is turned off. That's one of the applications. This is see the graph here. And there are also P channel MOSFET. This is called a P channel, and this is the P material, and this is N material, and this is a symbol. This is the enhancement mode, and this is called the depletion type transistor with a P material here with M material here. This is the solid line here. So they are the symbol of the transistor actually is quite varying, but in here I just want to introduce to you the Mosfet enhancement mode, and this is the older version of the field effect transistor called the junction field effect transistor, and this is the Mosfet, but this is the depletion mode, and the way to identify it is that the enhancement mode we have dashed line here, just as we stated before, and for the depletion mode we have the solid line here. And the way to identify whether it's N channel or it's a P channel is that using the arrow here, because in N channel, okay, in N channel here, we will create the N material here, and this is P, so the arrow should point from P to N, right? So that's why it's point from P to N. Similarly, because for the P channel MOSFET, we will create the P material here, and P point to N. That's why the arrow point from the gate to the outside here. So we have the one way to identify whether it's P channel or N channel. We use this arrow here. So in enhancement mode, MOSFET, okay, the voltage across gate and source must be positive, because the enhancement mode, for the enhancement mode, originally there is no charge here. We need to have the positive voltage here to create the N channel here. So for the N channel enhancement modes, we need to have the positive voltage here. And for the enhancement mode P channel, we need to have negative charge here, because originally there are no tunnel here, and we need to apply negative voltage here to attract the hole here. So for the P channel, we need to apply the negative voltage. Okay, so this is something like for the bipolar transistor, like a PNP transistor, we need to have the positive voltage here to have the IB current to turn this one on. So you can compare this one with the bipolar junction transistor, the NPN type. Yeah, these two are similar. And for the PMOS and enhancement type, you can consider it also using the NPN transistor here. For the NPN transistor here, let me draw it better. For the PNP transistor here, you need to have the negative voltage here such that we have the current flow through this way. Okay, so this is similar to the PNP bipolar junction transistor. But for the depletion type, the operation is working inversely. For the depletion type, okay, it has a negative. You have to apply negative voltage. And for the depletion type PMOS, you have to apply the positive voltage. Let me state the reason. This is the depletion type voltage. This is a channel. So this channel, okay, is conductive. So the current can flow through this two terminal, but it's conductive. So is not, we cannot use it in the amplifier as we used before. So when we apply positive voltage here, okay, we can make the tunnel. Thinner. For example, this original tunnel, the P tunnel, and it becomes a conductor, like a metal, although not as conductive as a metal. But by applying the positive voltage here, this tunnel will be we work that this way, and that will make the current saturate. Means that the current cannot increase infinitely. So the current will meet a threshold and the current can no longer increase. We will look at its characteristic curve to understand this. So the PMOS, for the depletion type, you have to apply positive voltage. For the NMOS, you have to apply the negative voltage. But since we emphasize on the enhancement type, okay, so you don't need to worry about too much about the depletion mode unless that you were working on the analog circuit in the future, and in the case that you will use depletion mode Mosfet. Okay.